Good afternoon, everyone. Thank you so much for joining us. My name is Katie. I'm with the Noaa Central Library. This seminar program we run provides an educational forum for the presentation of ideas, research updates, and news in support of Noaa's mission. Please note this presentation is being recorded, and your name and email and questions will be shared with the presenter after the fact. As an attendee, you were muted, so please place all questions in the question panel. Questions will be asked at the end of the presentation. And if you have any technical issues, such as there is no audio or you do not see the screen, please try logging off and back on, as that solves most issues. And with that, I'm going to present our speaker today. Our presentation is a beginner's tutorial on Git and GitHub. GitHub is a code hosting platform for version control and collaboration. At its heart, it's an open source version control system, or VCS, called Git. So together with Luke Thomas, he is going to show you all how to work on this or create with this GitHub. Luke Thomas is an associate research professor with the North Gulf Institute at the Atlantic, Oceanic, and Meteorological Laboratory in Miami. He helps manage the omics program at AOML, developing laboratory and computational methods for environmental DNA and microbiome research, and deploying them in marine environments across the Atlantic and global ocean. And with that, I want to turn it over to Luke.
Thank you, Katie. Yeah, as Katie said, my name is Luke Thompson, and I'm based at AOML in Miami. And so as part of my omics research, so that means I work on biological sequence data and other types of large biological data sets, I use a lot of software, and we develop some software as well. And so we like to use GitHub to manage our software and our projects, and GitHub and Git offer a really nice interface to do that. So what you're seeing here is our AOML omics homepage. This is an organization on GitHub, and if you look at GitHub, or if you browse around, you'll find that Noaa Gov has an organization. Some of the different labs have their own organizations. And then individual Noaa employees can create their own GitHub accounts. And so those are users that can use those different, work within those different organizations, or just create their own projects, which are called repositories in GitHub. So what I'm going to do today is, I don't have any slides per se. I'm going to just show you GitHub from the web browser, which is the main interface for using GitHub. And I'm going to walk you through a tutorial that I've developed for GitHub. So I click on this tutorials link, and this is a repository that we have under our AOML omics organization. And then I'm going to scroll down, and you can follow along. I'll put this link in the chat if I can. Maybe that's not going to work for me. So
Luke, you can put that in the chat, and I will make sure I share it out to everyone.
Sure. Unfortunately, I'm not able to use the control panel, so I'm going to just keep talking, and if you want to put that in there, hopefully you can read it. It's in the upper left hand. It's a little small, but it says
yes, I got it. Thank you.
Got it. Great. So that'll be something you can follow along either now or afterward, if you want to see the tutorial and follow along on your own. So I'm going to click on the Git and GitHub link here, and this is where we'll work from today. Now I've taught this material before. I taught a course on Python when I was in San Diego, a course at Scripps, and the lecture for that is linked here. So if you want to get perhaps a different version of the material or a deeper treatment, check that out. And but I'm going to start with an introductory video here, if I can. And this is I think it's nice to get multiple introductions to GitHub, because it's kind of a new concept. It took me a long time to figure out what it really was, and so let me see if I can make this play. I'm having a little bit of a responsiveness issue here.
Okay, what is GitHub? Well, GitHub is a platform that helps people solve problems by building software together. So, how does it work? This is Sam. Sam works on tractors all day, but not in the way you might be thinking. She builds the software that helps make tractors more efficient. And she does this on GitHub with the help of her team, BJ, Melinda, and Mike. Now, even though they all work on the same project, Sam and her team don't all work in the same part of the world. This is Eddie. Eddie also works on tractors all day, except he actually works on the tractors all day. And this is the Harvester L700. It's the latest flagship in the company's fleet of tractors. It's full of sensors and processors that produce a ton of diagnostic data. He has a great idea for how farmers might share their data and improve their harvests. So Eddie opens an issue on GitHub. Issues are discussion threads where people can report bugs, request features, or even just ask questions. Sam is the first one on her team to see Eddie's issue, and she thinks that BJ would be the best person to start the job. And here's where we get into the nuts and bolts. Eddie isn't the only person using the Harvester L700. All over the world, other tractors are collecting moisture data, and they need to keep running smoothly even while BJ is working on the new features. He needs a dedicated place to experiment, so none of his changes end up on the farm before they're ready. So he creates a branch of the code, an alternate timeline where he can safely make changes to the software. Now he's ready to start writing a new feature. GitHub tracks BJ's changes and saves snapshots of his progress. When he's ready to collaborate on the changes with his team, he opens a pull request on GitHub. Pull requests let you show others the changes you're proposing so they can review and discuss them. This means BJ's teammates can help with roadblocks and even make improvements. On GitHub, everyone has a copy of the project. So if Melinda has an idea for something that will help make BJ's work even better, she can add it to the branch herself. GitHub keeps a record of everyone's contributions and feedback in the pull request, alongside relevant messages from the team's other systems. Once the team has signed off on the changes, BJ can incorporate the new code into the project. The new feature will be available to everyone as soon as he merges it in. Now farmers everywhere can all benefit from Eddie's great idea. But this is really only the beginning of the story. Because GitHub is the largest community of developers in the world, with millions of people sharing their projects, Eddie's idea could end up helping people in unimaginable ways. What kinds of problems are you trying to solve? Whether you're an engineer, enthusiast, or even a farmer trying to harvest grain, software touches every corner of our lives. GitHub is where people build that software. It's how they build software, together.
All right, this section of my presentation was sponsored by Microsoft, but I think that's a great introduction, because you know, pictures are worth 1,000 words, and you can see that, you know, in addition to being a code sharing platform, GitHub is also a social network, right? You can write messages to your collaborators and tag people and tag issues and what we call commits and pull requests, and we'll learn about all that that jargon now. So yeah, so we're going to dig into this tutorial now. And so as Katie said in the introduction, GitHub is a code hosting platform for version control and collaboration. and it lets you and others work together on projects from anywhere. So at its heart is, at the heart of GitHub is Git, which is an open source version control system. And Git is kind of what's working under the hood that allows everything that's happening on GitHub to happen locally on your computer. So I'm going to show you this image. And so you can kind of think of these two things working hand in hand. So Git is the software, the kind of the core engine of GitHub. And it generally, you think of it more as working on your local computer. So you're doing a lot of the coding and development locally, and it's tracking all the changes you make and the commits when you commit changes to your code, keeping track of different branches and forks and these things we'll talk about. So it's basically a version control system, whereas GitHub is the cloud-based hosting service for the code repositories, and it allows you to share code with the world, and it has all this social networking capability as well. So the key kind of core workflow within GitHub is important to understand, and so there's a variety of steps, and we'll see a workflow of these in a second. So the way it generally works is you create a branch, which is a copy of your code that you're going to work on, and we saw this in the video where there was the main blue code of the blue combine, and then there was the green one that branched off, and so that's a branch where you can work on existing code and make changes to it. If you're just doing a new project and it's just you and another person, you might just have one main branch and you might not have a side branch. That's okay too. And so then you make changes to the code, and occasionally you will commit those changes. So these are little milestones, after you've done something important that you want to record that commit, and you provide a short message describing what you did so that you and others can follow your work history. And so you can actually roll back to different stages, different commits in the past if you want to go back in time, because each commit has a unique identifier. And when you're done making changes to the code, you then can open what's called a pull request. So this is where you can pull your branch into the master branch. So we have this idea of pushing and pulling. So when your code is ready to be merged, you can say, I want to push it to the master branch, and then whoever's in control of the master branch can pull your code. So it's called a pull request. And then there's a review process where the code isn't merged yet, but you have made the pull request. So now it's an open discussion. You're kind of declaring your intent to merge your code with the main code. And so there's a review process here. You can then use all these sort of social media aspects of GitHub to deal with the code and improve it. In some cases, you can deploy the code to make sure it runs. If it's kind of code that you would want other people to run, you can deploy it and make sure it works in a test setting. And finally, you can merge that into the master branch and then close that pull request, or close and delete that branch, so you've now merged it into the code. So a couple other terms, and then I'll show you some visual representation of this. Is a repository. So a repository is a GitHub project that encompasses all the files and folders and small amounts of data that are required for that project. So it's the whole thing, the whole project. Clone is to make a local copy of a project that exists remotely. So clone is like to download a GitHub repository to your computer so you can run it or work on it. And then we have issues, and this this is the social media aspect of GitHub, where you can create issues on GitHub, which then are opened. It's an open issue. You can say, okay, we need to fix this. You can tag people, you can add hashtags, etc. And then eventually, those issues are worked out and they can be closed, which will be reflected in the code. So if I click on this GitHub guides link, and it's going to show you the GitHub flow. So this is what we just went over. So here in this top arrow, this would be that blue Combine track that we saw in the video, and then in this darker blue below it, that would be the green that we saw in the video. So the first step would be, this all assumes that there's an existing project that you want to commit to. That's kind of the best use of GitHub. Although, as I said, you can do smaller projects where there isn't a big, an alternate branch. But in this case, so yeah, we're going to create a branch, and that allows you to work on something without making changes to the main code. Then you add commits, and these can be seen as milestones along the way. Then when you've made enough commits that you feel it's a substantive change to the code that you want someone to review, you open a pull request. And so again, that's a request to the managers of the main branch to pull in your code, to pull in your changes to improve the code. So then there's a discussion period where people can review your code, give you feedback. You can make changes to the code. They can make changes to the code to improve it. Then if there's a need to deploy or test it, here's when you would want to test and deploy the code. And then finally, when everybody's happy, the code can be merged, and that will then sort of close that pull request. You can delete the branch if you want that you're working on, and you can also signal that you want to close certain issues that were addressed in that pull request. So that's sort of the GitHub flow. And then there are some Git commands, and these are more for the command line. So for today, I'm not going to go through the command line itself. That's important, but you don't need to work on the command line to get a basic understanding of Git and GitHub. A lot of the stuff you might want to do with GitHub, you can do from the website. But there are definitely a number of commands that generally begin with the word Git, the Git command, and then a second command that either, in this case, initializes a new repository or clones a repository or adds a change or commits a change. You can also get the status of a repository, show which branches are being worked on locally, merge different development lines, pull updates from GitHub, or push your changes up to GitHub. So this gets to that pull push idea. It's sort of a difference between pulling something, either pulling it from the GitHub to your local version, or pushing it back, or in the case of the administrator of the master branch, pulling someone else's branch to merge into the master. So as I said, we're going to focus on GitHub.com today. And so when you are ready to start using GitHub, you're going to want to create an account. And so Noaa recommends that Noaa users, keep just sort of like your email. You keep your Noaa email separate from your personal email. You have a different account generally. Same thing for GitHub. If you've used GitHub in a previous job or for personal stuff, you might want to create a new account that's specific for your Noaa work. And so, give a little thought about what you want your username to be. It's possible to change it later, but it's hard. A lot of those, references that, people might tag you would be lost if you change your username later. So give that some thought. You're going to end up with a user account that then, when you want to see your repositories and your stuff, you would go to github.com/your username, and all your stuff would be there. So we have users, so each of us can have a user account, and then there are also organizations. So this AOML omics account is an organization account that has different users that use it. So I'm just gonna check the chat here and see if there's any questions. I don't see anything, but if you have questions, go ahead and ask those. So what we're gonna do now with the remainder of the tutorial is we're going to follow this.
Luke, I'm going to break in a second. We did have a question, if you're open to answering that now.
Of course.
The question is GitHub FedRAMPed? Excuse me.
I guess I don't totally know the implications of that process. What would that imply to be FedRAMPed?
I'm going to let our asker provide a little more details. And I'm going to move on to, we do have another question. Has any of the Noaa policies about GitHub changed since 2017 that you are aware
of? There was, not that I'm aware of. I believe that's around the time there was a policy. Yeah, I see here there's information. So the main Noaa GitHub account is called Noaa.gov, and it has just 2 repositories. It has this Noaa affiliated projects, and so if you have a lab or a major project, you can ask to, or you can actually make a pull request to this README document and add your project to your lab. So we added, the AOML, for example, lab organization here, and so that when people go to Noaa.gov, they can see the projects that are there. But if we go to this general information, I see it was last updated 2017, so that's that coincides with the question.
Yeah, we had some clarification that FedRAMP stands for the Federal Risk and Authorization Management Program, and it standardizes security assessment and authorization for cloud products and services used by U.S. federal agencies.
Okay. So I think that most of the guidance that people are going to want to refer to is here under this information repository, under the Noaa.gov organization, and it has specifically some information about a disclaimer and license. So code software is typically licensed via one of several different, licenses that have different properties of being more or less restricted and open access. So software created by the U.S. government is not subject to copyright in the U.S., and there's a clear statement of what the license statement should be is here. There's also, as I said, a disclaimer about where you can add that to your repository, or you should add that to your repository. Regarding different procedures in the FedRAMP process, I would have to refer people to the Office of the Chief Information Officer. I think they would be more qualified to talk about that. I'm not a federal employee, and I have not not been fully briefed on all of the different considerations and whatnot, so I don't want to speak for them, but I think this document here does provide some guidance.
Great. Thanks, Luke. Is the link to that under the GitHub Noaa Gov
Yes. Yeah.
space?
So
Okay.
the URL is just github.com/noaagov. All one.
Wonderful.
All.
Okay. Thank you.
Yep.
Continue.
Great. So yeah, and again, so there's this other repository called Noaa Affiliated Projects, and if you click on that, you'll see different GitHub, like the Central Library has an organization, and looks like I would need to sign on to access that, but or PMEL has one, so you can see all the different software projects. And what we do at AOML is we have forked different repositories here. And so what that means is we create a fork is kind of like a branch, but it exists on your own user account. And so rather than transferring all the administrative rights for each repository to whoever manages the AOML organization on GitHub, people can still maintain the administrative rights for their repository. They have control over what gets merged and what doesn't, but people can find that repository by going to this AOML organization or our AOML omics organization. So that's a nice feature. So yeah, continuing, we're going to go through this Hello World tutorial. So we're going to create a repository, create a branch, make and commit changes, open a pull request, and then merge the pull request. So I'm going to click on this link here, and I'm going to split my screen. And okay, so where did that go? There we go. Okay, so on my left here, I can see the tutorial, and on my right, I have my own user account. So what I'm going to do is follow along. So we already know what GitHub is, and to do this tutorial, you don't need to code, you don't need to use the command line. Of course, it's great to build those skills, but for the purpose of this, you don't need any of those skills. So the first step is we're going to create a repository, which is basically a project. That's the terminology in GitHub jargon. And so typically when you create a project, we'll create a README file, which is what you see when you first open the project. So for example, the README file for this Noaa affiliated projects is this file here. It's a markdown file, and I could click on it, and this shows the sort of rendered version. But if I click on this raw link here, I can see the unrendered version, which is a markdown format file, which is a way of rendering text in a much simpler way than, say, HTML, which is what's called a markup language, but it's the same idea. In any case, we're going to want to create a README file. That's where you can provide some information about the repository. And typically, when you create a repository, you can specify a license file as well, and some other things. So what we're going to do is create a new repository. So I'm going to go to my user account. So to do this tutorial, you do need to create an account. So this is my account homepage, and I'm going to click on this plus sign here, and I'm going to select new repository. So the owner is going to be me. I also have access to these other repositories, but I'm just going to make it under my own account. And then I'm just going to follow along the instructions. So we're going to call this Hello World like they suggested. And I'm going to give a little description. It's always good to have that. That'll show up at the top of your repository. Can be public. And we're going to add a README file. And we don't need to, well, we won't worry about this git ignore. This chooses which files not to track. Depending on what kind of coding you're doing, you might want to define that for a specific type of code. And we can define a license, but typically, I can check here. I don't think there's a US government license here. I'll check. So I think I'll leave that blank for now. And then all we do is create repository. So this will set main, the main as the default branch, and we could change that to something else. But interestingly, this used to be called master, and GitHub decided to do away with that language because the term master kind of had a connotation with slavery and that sort of thing, and they wanted to do away with that. So it's a little interesting bit of trivia. So it's now called main is the default branch. So we're gonna create that repository. So we've now created a repository. So we can now start doing some GitHub stuff. So we want to create a branch, and so this is the way we could work on a side branch without affecting the main branch until we're ready to do that. So we saw the flow before, so this sort of the way that looks should be familiar. So we want to go ahead and click here, and we can say find or create branch. So we can say we can call this my branch, and to create that we just click here, and so now we've created a branch. So next is we can make some changes. So we can click on the README file, and then we can click on this pencil icon. So this is where we can edit the file. So we're actually editing our content of our repository. In this case, it's the readme.md file. Typically, we would do more editing of code locally and then push those changes back up to GitHub, but it's also possible to edit directly on the internet. So we can edit this file. So we can add some text there. We can also try some other markdown text. So
We do have some questions, Luke, if you don't mind me asking while you're doing this.
sure.
Okay, the first question is, when you fork a repository and changes are made, are these changes reflected only in your forked copy, or do they propagate to the main repo without a pull request?
Right. No, they are only in your forked repository. So yeah, they're only in your forked repository. So oftentimes, like there's different. I mean, there can be an extreme example is I developed a GitHub repository when I taught this Python class, and it's been forked like over 200 times, but I don't think I've ever had anyone issue a pull request to like merge their changes back into the main branch. So it's just in the fork until you issue a pull request and it gets merged. So yeah, good question. All right, so I made some changes to the README file, and actually there's a cool feature here. I can see the raw text of the file, but I can also click on this preview and it will show me what it's going to look like when it's rendered. So I made some changes. Then I can provide a commit message. And I can add more to the description, but usually just a short, one sentence or less is great. You want to be succinct and specific. And I'm going to commit that directly to that branch. And so I click on commit changes. And so now those changes have been made. And so if I view now my branch that I created, I'm going to see the new version, but I can click on this drop down and view the main branch. And now I see the original version. So those two branches are now separate. So for a fork, if you made a fork of this repository, it would be under a different URL. So instead of the main branch, which is github.com/LukeNoaa/hello world, it would be under github.com/your username/hello world. So it's not quite as easy to switch back and forth between those different forks as it is between different branches within the same fork. But otherwise it's generally a similar idea of you've got a copy of the code that can differ, and the way that those changes get merged and dealt with, and you can imagine it could be kind of complicated to resolve conflicts and things. That's all handled by Git, which is the version control system. So that's kind of where the heavy lifting happens, where it will check, that things are compatible, and if there are issues, it will warn you if you're going to overwrite something. If there are conflicts, you'll get warnings about that, and you'll be given a chance to fix those. But this is a very simple example, so we're not going to have any conflicts. We're just changing a single file. So I'm going to go back to the branch that we're editing, and then I'm going to go to step 4 where it says open a pull request. And so we're going to click on the pull request tab here. And it said my branch had recent pushes 2 minutes ago. And so we're going to click compare and pull request. This is a slightly newer feature, but this is a good one. We can either do a new pull request or this compare. So it's then going to open a pull request, and
Luke, can you make your screen slightly bigger on the left-hand side?
Yeah.
It's really hard to see.
Yeah.
Thank you.
Mm-hmm.
That works.
Yeah. So then on the right side, we've clicked on compare and open a pull request. And so what we're doing is we're comparing this new branch that we created to the main branch, and it's saying that these branches can automatically be merged. So it's automatically going to use if it's just one commit, it's going to use the name of the commit as the name of the pull request. If there's multiple commits, you'll have to give it a new name that's kind of descriptive. We can write some comments here. And if we had issues or users, so issues are up here. I'll show you those in a minute. If we had issues or other users we wanted to tag, we can do that here in the comment. But let's see. And let me go back. I'm not seeing the same. Let's do this new pull request. There we go. So what we want to see, this is a nice summary that you often get when you are looking at individual commits or all of the commits that are going to be included in a pull request. So here we just have one commit. You set the date here and then the name of the commit and the unique identifier, and then it shows the changes to the file. Any kind of text file, it'll show changes. So it's showing that we deleted this line number 2 here, and then we changed it to something else and then added these other lines. So all this in green is new text, and in red is the text that was removed and has line numbers. So it's a very handy reference to see what was changed. And this is all powered by the Git version control system. So we're happy with that. So we're going to create a pull request. Again, we're going to merge this my branch into the main. So we're going to click create pull request. And so at this point, if it was a collaboration, you would stop now. The people that subscribe to the repository would probably get an email saying, someone has issued a pull request to your repository. You can also, leave a, say there was someone named Joe, you can say, hey Joe, like checked out this pull request, or what do you think about this commit, etc. And there's this discussion process, but eventually whoever has the authority to merge the pull request can do that. In this case, since it's my own repository that I created, I'm allowed to merge my own pull request. So it says this branch has no conflicts with the base branch, so merging can be performed automatically. So I can click merge pull request. It's going to give me one more chance to make any, cancel or to add comments, and then I'm going to click on confirm merge. And so now it was successfully merged and closed. And so I can go ahead and delete that branch. And so now if I go back to my my repository by clicking on this link up at the top, I just have the main branch now, and I can see that the main branch now has the updated code or the updated text of that file. Yeah, so there's that step. That was step 5, and that's it. So this is something that you can do on your own and experience it and see how it goes. As I mentioned, there's another nice feature here called issues, where you can open an issue and say make more changes to the README, and I can submit an issue. And let's say we can add another issue and say add a license file, and I can say check out guidance from Noaa Gov. So now I've got these 2 issues here. I can click on that license file, and that's going to make a link to that page, and so now I can see there, so that you can add links to users or organizations. You can add links to, you know, add to issues. So that number 2, that links to issue number 2 here. And you can also link to different commits or pull requests as well. So there's some really nice kind of tagging features that GitHub provides. So let me go back to my tutorial here. So we did the Hello World tutorial. The only other stuff in this document is more command line guidance about when you're ready to use the command line, you know, a bash prompt or something like that. You can, and Git usually comes pre-installed with the Mac OS. For Windows, you can download a program called Git Bash, and that will give you both Git and also a bash shell. That's a pretty nice tool as well. And so there's some different kind of recipes here for, you know, setting up your Git environment, setting up your working directory, and then some examples. So how to contribute to an existing repository, how to start a new repository and publish it to GitHub, how to contribute to an existing branch on GitHub, and how to fork an existing repository and make some changes. I've also got some different additional Git commands here, some guidance on managing remote repositories. So there's, for example, the main example would be there's the main branch is an upstream. It's called an upstream copy, and then you have your origin, which would be your fork. So it's basically when you have a fork, you want the original has a name and your fork has a name, and typically we use the name upstream for the main one, and yours would be called the origin. But you can change those names, I believe. And then there's some advanced stuff here to customize your command line prompt and add tab completion. And I think that's it. So yeah, I hope this is useful for folks. Again, I think the link has been shared with you, so all that content is there. And with the remaining time, I'd be happy to answer any more questions.
Great. Like, we had a question earlier on about what is the process during the review phase?
Yeah, that's a great question. So this really depends on who you're working with and what kind of procedures that they want to set up, or that you as a group want to set up. So you could imagine if you were working in a company or a large research group on a project, that you would want to have some kind of ground rules for how you're going to handle reviewing code. You know, so for example, you know, who would be responsible for reviewing a certain part of the project, or who has the final say, or how you establish a consensus, whether you can merge your own pull requests or not. Typically that's frowned upon, but in a small project, or if you're the only person working on your project, then you don't have a choice but to merge your own pull requests. But in a very collaborative environment, you know, where you've got many people working on a project, you know, somebody else should review the code and kind of decide whether to merge your changes, so that you can have some checks and balances. So I guess there aren't, as far as I know, there aren't any rules about that within Noaa or anything like that. It's really up to the research group and team to make those decisions.
Great, thanks. We have a few more questions. If you contribute to someone else's repository, can you select the license for your contribution? Or does GitHub presume that if you submit a pull request, you consent to your contribution being licensed under the same license that the repository owner selected?
That's a great question too. I'm pretty sure you are bound by the license that is, especially, if you want to make your own fork and like keep it separate and kind of it becomes its own thing. I think depending on the original license, you might be able to change the license. If it's that I'm not sure about, right? That might have some issues, but it might be possible to change that license if you create a new version. But I'm almost certain that if you are making edits or pull requests to an existing repository, that you're going to have to abide by the license of that repository and not be able to change the license.
Great, thanks. Another question, can you add external existing open source code to a repository?
Yeah, I think so. I mean, that goes to the license question. So if the code was licensed in a permissive way, the most permissive licenses allow you to reuse code for any purpose, even for commercial use, those sorts of things. So it would depend on whatever license was issued for the code that you want to use. But generally, I mean, GitHub used to be a kind of a small company, or even I think maybe a nonprofit, or it was bought by Microsoft a few years ago. But for the most part, it still remains a home for lots of open source projects that are not proprietary. So a lot of code that you would find on GitHub or even other places is open source, and you can use it and reuse it and do whatever you want with it.
Great, thanks. Our next question, could you talk about and/or explain blame?
I'm not sure I understand the question. Is this blame for? Is this something referring to something I mentioned, or is this in relation to, like, say, if there's issues with the code and like attributing who's responsible for a problem in the code or something like that?
I'm not sure. I hope that person who asked the question can clarify in a moment. But I'm going to move on to another question. In addition to being social collaborative, it seems like the GitHub resource and Git can also be used to manage development of your own code. In that case, I assume you don't need GitHub, but there may be benefits for documentation.
Yes, I think that's accurate. Yes, I'm pretty sure you could use Git locally as a version control system and maintain repositories. In fact, I'm sure you can. And in fact, I should point out that GitHub is not the only game in town for as a Git server. There are other cloud-based platforms that do something similar to what GitHub does, and I think you could even set up your own Git server. So you could have your own GitHub, your own Git server, or you could not use one at all. But I think there are some advantages to using GitHub. It's a nice user interface. I guess it does add another layer of pushing and pulling code, but it also provides a storage of your code. So if you were to lose your computer and lose your copy of your code, it would still be on GitHub. And I think people spend a lot of time on on these kind of projects. So I think that's a valuable thing, and it also tracks, all the issues. And so you could do a lot just as a individual researcher working, in isolation. You could still have issues. You could still track issues. You could still take advantage of the GitHub interface. And if you were concerned about privacy, if you wanted to keep everything private, you could pay for a private account on GitHub, or you could set up your own server or use a different server that that was either private or not shared with the public, or something like that. So I think, yeah, there's some different options of how you could use it.
Great, Luke. We did have a little bit of clarification. Blame apparently is a GitHub command feature. It's designed to help you determine who made changes to a file. Despite its negative sounding name, Git Blame is actually pretty innocuous. Its primary function is to point out who changes which lines in a file and why. It can be a useful tool to identify changes in your code.
Okay, well that's cool. Yeah, I didn't know about that command. So I think the person asking the question knows more about this than I do, which is not a surprise. I'm definitely not an expert at Git. I just enjoy, I guess, teaching about it. So, but certainly that's a new one for me. So that's great.
Great. And we do have one last question. If we are reviewing a code as a group, should we establish an order to review to avoid conflicts, or would conflicts be easily solved using GitHub itself?
Yeah, good question. Probably it would make sense to to sort of compartmentalize the process. Like the individual pieces of code would have would work kind of using a module-based system, or have defined inputs and outputs, so that you could work on one part of the code and someone else could work on the other part, and that even if you made changes, that they would still fit together after those changes were made. But yeah, I think it's sort of like it's sort of like if you're working on a Word document with a group of people and you kind of pass it around. It's possible to merge those changes. Even Word offers a way to do that, and Git is very good at merging changes from multiple people, but you could have conflicts. So it's that requires a little bit of definitely communication and some trial and error to see if things are working. So I think there are some potential hurdles, but it's generally there's some flexibility in how you manage those collaborations.
Great, thanks, Luke. And we are ending right on time. I see that it is just about to flip over to 2 o'clock. I want to thank everyone for joining us. Thank you, Luke, for giving this tutorial. There will be a survey that pops up at the end as you exit. So if you want to fill that out and give the library some details about what you would like to see next, or if you would like Luke to come back and do another tutorial, please let us know in that survey. With that, thank you all. I hope you have a great rest of your day. If you do want to pass this on, we did record it and we will be posting it on the library's YouTube channel. Thank you again, Luke.
Thank you, Katie, and thanks everyone for joining.